Okay, this is question 37 in your multiple choice packet, and this is a great one to talk through because this question really doesn't look like anything that we've done so far, but it definitely ties into some of the key concepts we've talked about. So just a quick read through the flow of oil in barrels per hour through a pipeline is given by the graph shown above. Of the following, which best approximates the total number of barrels of oil that passed through the pipeline that day? So here's what I'm recognizing from everything I just read. I'm recognizing that the given function, the given graph, is a graph that has to do with a rate. So our y-axis, our dependent variable, because our independent variable is time here. Our dependent variable is some rate. So I know I make this analogy a lot, but I'm thinking that that's similar to velocity, where I have a velocity graph or a velocity function. And they're asking us for the total number of barrels of oil, which means we're trying to find an amount. And there's a relationship that pops into my head that I have summarized for you, and you need to be able to recall this and apply this. An integral of a rate gives you an amount, always. Okay, so again, my example is integral of velocity gives you distance traveled, net distance, so not your total distance traveled, but again, the change in position. So if we want the change in number of barrels of oil from the amount that you had to the amount that has passed through the pipeline that day, the amount at the end of the day, then we're going to have to integrate that rate, the flow of oils, to get the amount. Okay, if you want to think about, so let's now put our particular case in. Instead of talking about velocity, let's go with what we have, and ours is flow of oil. So I'm just doing flow times dt, and I'm saying that that is an amount of oil. Let's just do a quick look at units because that might help us here. So the flow is measured in barrels per hour. And then remember, this dt is a small change in your independent variable, and our independent variable here is hours. So it's going to be a small amount of hours. And if we actually do barrels per hour times hours, the hours cancel each other out, and we're ending up with number of barrels. Okay, because it really all starts with the concept. Now, maybe you got that concept, or maybe you just took a guess because, hey, we're talking about integration, so we're probably going to integrate. Well, how do I actually integrate this? Well, we have a graph, and they want you to think integration, area under the curve. Since I'm given the graph, that's probably what I'm doing. We also could be thinking fundamental theorem of calculus, but I don't have the actual function. So I'm thinking area under the curve. How do I find the area under that? And now you're probably going to rectangles and trapezoids and getting confused because what am I supposed to do here? So those are just methods, and I'd say if we're not asked to use a specific method, let's just try to get as close as possible. It does say approximate, so it's okay to estimate. So I don't know about you, but I'm seeing this is approximately a rectangle here. Okay, slightly under, but approximately. So if I do that, 24 times 100 is giving me 2,400 barrels are represented by that rectangle. And then I have sort of a triangle here, and I'm not really doing, I guess you could say I'm doing trapezoids, but I'm just kind of going as close as I possibly can. And for that triangle, I'm getting, let's just use some geometry, 1/2 base is 2 units along my x-axis, but 2 units here is really from 6 to 18. So that's a width or a distance of 12 hours. So if you want to write it as this is 18 minus 6, that's where I'm getting the 12. And then the height, this distance right here is from 100 to 200. So that's 100. That's giving me altogether 1/2 of 12 is 6 times 100 is 600 barrels. So I've got the 600 barrels plus the 2,400 barrels. So 2,400 plus 600 is about 3,000 when I'm adding those up. And I'd say this is fair game for a no calculator question. They give us pretty nice numbers to work with. That's how I'm getting an answer of D for my final answer. Hopefully that helps. Again, very different question, but a good one to kind of think about how do we process and apply what we know to an unfamiliar situation.